Okay, let's do the second one on 11.5. So far, we've only dealt with series such that the inside the sequence part was all positive. Let's change that today and let's start working with ones that we don't have to have the insides being all positive. Okay, and we're going to look at alternating series. So what's an alternating series? It's a series that goes plus minus plus minus plus minus. So how are we going to make it do that? You got the sum, n equals 1 to infinity, and do a minus 1 to the n times a to the n. What's that going to look like? When you put in a 1, that's going to be a minus 1. That's going to be a minus a1. Then it's going to be a 2, they'll square kill the negative, so it'll be plus a2 minus a3 plus a4 minus, and it keeps going forever. Okay, or we could start with a positive. So summation n equals 1 to infinity of a minus 1. To make it start positive, I'm just going to add 1 to the exponent. So be n plus 1 a to the n. So now when you stick in a 1, you got a 2 here that squares it, kills a negative. And so your a1 will be positive, then your a2 will be negative, and your a3 will be positive, your a4 will be negative, and then on out forever. Now, when we work with these guys, we're going to keep these positive. So the ANs are positive. We're going to make them negative by putting this alternating plus and minus 1 in front of it. Okay, otherwise, if I didn't know if AN was positive, I wouldn't know it's going to plus minus plus minus. Now, I'm going to do a kind of a proof, but I'm going to do the specific example and let you read through the book. He does it with the general example. I think it'll make more sense if I do it a concrete one first, and then you read the abstracted one. I'm going to take the summation n equals 1 to infinity of a minus 1 to the n plus 1 of 1 over n. Now, I've already worked with this one a good bit, not this one exactly. We worked with that. And we know that the summation of 1 over n is p series with p equaling 1, and that's going to diverge. So we know that that diverges. But what about when we make it be plus minus plus minus? This guy looks like what? Stick in a 1. That's going to be positive, so I get 1 over 1, so it's positive 1, then a minus 1 half, a plus 1 third, a minus 1 fourth, and a plus 1 fifth. Let's look at some of these pieces. So S1 is equal to what? Well, that's your first term. That's 1. What's S2 going to be? S2 is going to be 1 minus a half, so that's a half. What's S3 going to be? Well, that's 1 minus a half plus a third. I did that one earlier. Let's see what we got. That one is 5/6. Unless I screwed up. And then what's S4 going to be? S4 is going to be that plus that plus that plus that, which is 14 over 20. And again, I could have screwed up, but so if you look at it, everybody's positive. Now, the pieces, the sequence pieces are not positive, but each one of the partial sums is positive. And if you look at them, each one of the partial sums is less than 1. Now, can we use some of those ideas to show that this guy either converges or diverges? Well, let's look at it a little closer, okay? So, what's S1? Well, that's 1. Well, what's S2? S2 is 1 minus a half. Well, 1 minus a half, well, that's less than 1. So that's less than S1. What about S3? Well, S3 is 1 plus, I'm going to rewrite, okay, I'll write it twice. That's 1 minus a half plus 1/3. Let me rewrite this. That's the same thing as 1 plus a minus 1/2 plus 1/3. What's the sign of a minus 1/2 plus a third? The 1/2 is bigger than a third. So this is going to be negative. That's 1 minus a number. So that's smaller than 1. But 1 was S1. So I know this guy is less than 1, which is equal to S1. So that's less than S1. What about S4? Well, that's 1 minus a half plus a third minus a fourth. So that's going to be 1 plus a minus half plus a third. I know that's a negative number. And then I added a negative 1/4 to that. Well, I took 1 and I took 2 numbers off of it. Well, that's going to be smaller than 1. S1 is 1, so I know that's smaller than S1. I'll do one more and we kind of get the idea what's going on. Get S5, well that's equal to 1 minus a half plus a third minus a fourth plus a fifth. Okay, so that's going to be 1 plus a minus half plus a third. Okay, and then it's going to be plus a minus 1/4 plus a fifth. What do you know about this number? 1's a positive, but that's a half minus a third. That's a negative number. That's a quarter minus a fifth. That's a negative number. So I got 1 minus 2 numbers. That's got to be less than 1. And so that's got to be less than 1, which S1 equals 1, so it's got to be less than S1. So I know that Sn, make that a big N because that's what I've been doing. Sn is less than S1 for any n that's bigger than 1. Be less than or equal to if you put an equal. So the entire sum is less than the first term. So the entire sum is less than 1. Okay, that's interesting. So I do know that Sn is bounded by 1, or S1, however you want to look at it. Now let's look at it another way. So I know that all the terms are bounded by 1. If I could get this to be an increasing sequence, then it'd be done, and I could have it converge. But I don't know if it's an increasing sequence, because here, as you saw the terms, they did bounce back and forth. So it's not necessarily an increasing sequence from the very first thing we did. But let's look at the even terms. What is S2? S2 is going to equal, that's S1 plus this, that's a half. Okay, now how about S4? What's S4 going to be? That's going to be, I'm going to take this one and this one and this one and this one. So that's going to be 1 minus a half. So S2, let's go and make sure you know what S2 is 1 minus a half, which equals a half. S4 is going to be 1 minus a half plus 1/3 minus a fourth. Okay, what do you know about this? That's S2. What do you know about 1/3 minus a fourth? That's a positive number. So what do you know about S4? Is S4 bigger than S2? Well, here's S2, and I added a number to it. So you can't take a number and add a positive number to it and get smaller, you get bigger. So I know that S4 is bigger than S2. What about S6? S6 equals, this is going to be 1 minus 1/2 plus 1/3 minus 1/4. That right there is S4. What we're going to do now to get S6, you're going to add to that 1/5 minus 1/6. 1/5 is bigger than a 6, so that's a positive number. So what's 1/6? What's S6 is S4 plus a number. So I know S6 has to be bigger than S4 because there's S4 and I added something to it to get S6. So I do know that S with 2, 4, 6, 8, and on out the even numbers, so 2 to the n, I know that that is an increasing sequence. If I take the positive numbers, so it's just 2n. So if I take the positive numbers, they will, not positive numbers, if I take the even numbers, 2, 4, 6, 8, 10, take the even numbers, they're going to be increasing. So I got a sequence that's increasing, and the sequence, since all the SNs are bounded by 1, the S2Ns have to be bounded by 1. So this guy's increasing and bounded by 1. What can you say about this guy? It converges to, I don't know what it converges to, but it's bounded, it's monotonically increasing, and it's bounded. So I know that this guy converges. Okay, so I know that the even parts of this guy converge, and I don't know what converge to what. I'm just saying it converges to some number, I'm going to call it K. So I know the even parts converge to K. Now let's look at the odd parts. So let me write what we just did down. so the even parts, so S2n converges to some number, and we called it K. Let's look at the odd parts. How do we get an odd number out of this? You're going to take, so what are the odd ones? Look at the odd ones. So what's S1? S1 equals 1. S3 equals 1 minus a half plus a third. And S4, S5 equals 1 minus a half plus a third minus a fourth plus 1/5. Now if we look at that, what's S3? S3, look at this piece right here. What is that? That's S2. It is S2 plus 1/3. What's this? That's S4 plus 1/5. Okay, so what would how do you get an odd number? We take an even number, 2n, that's even. What do you do to make it odd? Either add or subtract 1. I like adding. Okay, so what's S2n plus 1? Well, that's going to end up being, if this was 5, what'd you get? You got 4, S4, so this is S2n plus 1, so you're going to get S2n plus 1 over the last guy. So it's going to be plus 1 over 2n plus 1. Okay, now, if I took the limit of the odd terms, take the limit of this guy, as this guy goes to infinity, where's this going to go? Oh, we already said that goes to k, so this guy's going to go to k. Where's this guy going to go as n gets bigger and bigger and bigger? That's 1 over infinity, which is 0. So we know now that the even terms go to k, and the odd terms also go to k plus 0, which is k. If the even terms and the odd terms go to k, there ain't nothing left. So the whole series or sequence of partial sums approaches k. So the sequence of partial sums approaches k, and so we can say that this guy right here converges to what? I don't know, but it does converge. Okay, stop right there.